not same substances. They are not same substances. They are totally different, but they are somehow related. Creatine, when it is methyl guanidine acetic acid nitrogen amine, that means that is creatine is an anhydrous form actually. These are the group of amino acids. They combine together and form this creatine molecule in the skeletal muscle particularly. And creatine creatinine is a breakdown product or a waste product of creatine phosphate and creatine in muscle, and usually produced at a fairly constant rate by body depending on the muscle mass. Remember this line. Creatinine is a byproduct of protein metabolism. That means first in our body, skeletal muscle produce creatine with the help of some amino acid. 3 amino acids are there. Creatine, and when that creatine molecule further metabolized, or we should say catabolized, then creatinine is produced, which is almost waste product and excreted urine. That means creatinine is a waste product or byproduct of creatine metabolism, or sometimes we should say the anhydrous form of creatine. That means when we take one molecule of water from that creatine which was synthesized in skeletal muscle, the remaining part will be creatinine. That means creatinine is just a waste product, and it's anhydrous form of creatine molecule, and the synthesis rate for this creatinine is almost constant. That means in our body, the creatinine is very, very constant unless we are healthy. That means if our kidney is very finely working, then our creatinine level is every day almost same. But it depends on muscle mass. That means for female and for male, we have a different level of creatinine in our body. Today we will discuss how creatine synthesized, how creatinine synthesized. Yes, energy source for muscle contraction. Last time we discussed the immediate source of energy is the creatine phosphate. That is also known instant source. That means that is the fastest source of energy for skeletal muscle. Fastest means that suppose our fastest snacks in our home, I said that is most popular in nowadays. Chow chow, whoever comes just boil and eat. That's why they said instant noodles. That means almost ready to use. Just put some hot water and it ready to eat. Similarly, in our muscle, particularly in skeletal muscle, this creatine phosphate is almost ready to use energy source, because just we add one phosphate molecule and definitely get adenosine triphosphate. So creatine phosphate is an instant source of energy for skeletal muscle. ATP provides immediate energy for muscle contraction from three sources. Yes, creatine phosphate, that is immediate source. During resting condition, storage energy to synthesize ATP. Anaerobic respiration, that is occurs in absence of oxygen and results in breakdown of glucose to yield ATP and lactic acid, that is anaerobic glycolysis. We discussed in the previous, we have a different source of energy. Aerobic respiration requires oxygen and breakdown of glucose to produce ATP. This is the most efficient one then compared to these first two, and we already know this. Then we will know how this creatine molecule is synthesized in our body. This is very, very important question. Generally, I should say, most often we ask this question, how creatine is synthesized in our body. 3 amino acids are required. Remember these. This is GAM, glycine, arginine, and methionine. Glycine, as you know, this is very simple and first amino acid. Arginine, this is basic amino acid. Methionine, if you remember, this is from gamma, that is acidic amino acid. And we know these 3 amino acids, when combined together, they produce creatine molecule. Site of biosynthesis. First step happens in kidney, but second step in the liver. That means there are 2 organs involved in the biosynthesis of this creatine molecule. Remember, this question generally asked in MCQ as well. At that time we asked which is not the required amino acid out of following. At that time we have 3 right answer and 1 wrong, or sometimes we just put 3 wrong and 1 right answer. Similarly, which are the organ peculiarly involved in the synthesis of this creatine molecule? That remember, you have to kidney and liver. And this is how they synthesized. See, we have arginine molecule and a glycine molecule. They combine together in the presence of enzyme amidinotransferase, or remember transferase, or better you remember amidinotransferase. That means these glycine and arginine molecule combine together to produce guanidinoacetate in the presence of enzyme amidinotransferase. And the one ornithine molecule is produced, which is turned to urea cycle, and that further metabolized into urea. And this guanidinoacetate state in the presence of another amino acid, methionine, we should say S-adenosyl methionine, further added here in that guanidinoacetate state and produce creatine molecule in the presence of methyl transferase. That means this methyl group from methionine is transferred to the guanidinoacetate to produce creatine. This is very, very simple reaction. You have to memorize 3 amino acids, 2 enzymes, and the first reaction in the kidney, second reaction in the liver. Once again, see, we have one arginine molecule, that is amino acid, we know, basic amino acid, glycine, very simple amino acid, and when they bind together in the presence of enzyme aminotransferase, one origin molecule produced with further metabolized in different pathway, and then this new product is guanidinoacetate. Now this guanidinoacetate transferred to the liver, and in the liver one methyl group is added with the help of this methionine amino acid into the guanidinoacetate, and in the presence of enzyme methyl transferase, and this new product is creatine. And we know if we add one phosphate molecule in this creatine, the new product is creatine phosphate, which is actually a stem source of energy. And creatine phosphate is generally stored in our skeletal muscle for instant energy. That means now we are able to produce creatine. If we add one phosphate molecule into this creatine, that is creatine phosphate, that is stored in our skeletal muscle. And whenever we need energy, that creatine phosphate immediately donate one phosphate molecule to adenosine diphosphate, and that adenosine diphosphate turn into adenosine triphosphate, which is the real currency of energy. Yes, distribution of body in creatine from liver transported to the other tissue. That means this is synthesized in kidney and liver, and once it synthesized in liver, then it transported to other tissue, mainly in skeletal muscle. 98% present in skeletal muscle and heart muscle. Yes, in muscle it gets converted to high energy source creatine phosphate or phosphocreatine, whatever you say, creatine phosphate or phosphocreatine, both are same. That means once the creatine molecule transported to the skeletal muscle or cardiac muscle, they convert it into phosphocreatine or creatine phosphate. This is how they turn into creatine phosphate molecule. Remember this. See, this is vice versa reaction. That means that this is bidirectional reaction. We have a creatine which we just produced or synthesized with the help of 3 amino acids, glycine, arginine, and methionine. And the 2 organs were involved there. One is kidney, another liver. Then that creatine is transported to liver, skeletal muscle or cardiac muscle from the liver and into the skeletal muscle. And in the skeletal muscle, one phosphate molecule is added to that creatine molecule, and a new molecule is produced that is called creatine phosphate or phosphocreatine. This is a very, very high energy compound or instant source of energy for our skeletal muscle. For this, we need one enzyme that is called creatine kinase or creatine phosphokinase. Both are same. And here, definitely we lose one ATP. That's why that phosphate group is added here. And ATP loses, that's why this ATP converted into ATP. And similarly, if we have a creatine phosphate, by donating this phosphate molecule, we can produce creatine again. That's why it's bidirectional reaction. This is reversible reaction, we should say. See, it's very, very simple now. We know how creatine is synthesized in our body. Then what happened to synthesis? After synthesis, it transported to the skeletal muscle and the cardiac muscle. In the skeletal muscle and cardiac muscle, one phosphate group is added to creatine molecule in the presence of enzyme creatine phosphokinase or simply creatine kinase. And the new product is produced, that is creatine phosphate. And this creatine phosphate is a high energy molecule for a instant source of energy. Yes, what is relationship between creatine and creatine phosphate now? Yes, definitely there is one relationship that they are creatine molecule just adopting one more phosphate molecule in the presence of creatine phosphate kinase enzyme. Creatine and creatine phosphate exist in a reversible equilibrium in skeletal muscle. Yes, we know that is bidirectional reaction, that is called reversible reaction. In skeletal muscle, approximately 1/4 of creatine exists as a free creatine and the 3/4 exists as a creatine phosphate. Remember this line again. That means suppose you have three creatine molecule, out of the four creatine molecule, out of that four, one is almost free and three are bind with phosphate molecule. That means you don't have always all creatine molecule with the conjugated phosphate molecule. We have nearly 25% are free creatine, while 75% are with one phosphate molecule added, and they're called creatine phosphate molecule or phosphocreatine molecule. This is the relationship. And the reversible equivalent between the creatine and phosphocreatine, we know that this is simply, we said this is creatine, we synthesized earlier with the help of three amino acid, glycine, arginine, and methionine. And the first reaction was in the kidney, second was in the liver, and that creatine was transported to skeletal muscle or cardiac muscle. In the cardiac muscle or cutaneous muscle, there was addition of phosphate molecule in the presence of enzyme phosphocreatine kinase or creatine phosphokinase enzyme. Then the new molecule is phosphocreatine or creatine phosphate. We know that. Then now creatine phosphate is a high energy phosphate compound. Yes, we said this is the instant source of energy for skeletal muscle. Creatine phosphate. Now we are in creatine phosphate molecule. We can easily synthesize these. This creatine phosphate acts as a storage form in the muscle. Muscle, just when we say just muscle, it means it's skeletal muscle. It's very simple that whenever we don't have very specific name, just we are saying muscle, that means skeletal muscle only. And it provides a small but ready source of energy during first few minutes of intense muscle contraction. Yes, this is definitely it provides very short duration of energy. Yes, we said it hardly 10 to 20 seconds only, but it produces a very instant energy, especially when we are in a something bad situation. Suppose you just to get some snake near you, you will jump very high, you can jump, and that intense confidence and energy comes, not confidence only, I should say energy comes from this molecule creatine phosphate. Yes, the amount of this creatine phosphate in the body is proportional to the muscle mass. This is very interesting line. The amount of creatine phosphate stored in our body is depend on how how much we are muscular. That's why there are many people, they love to make muscles. They have biceps, triceps, so many shapes they have. Yes, and the muscle mass is directly proportional to the concentration of this creatine phosphate. Always we say creatine phosphate is directly proportional to the muscle mass, because the more the muscle we have, more creatine phosphate we can store. That's why we said, oh, he is very strong man, like that, because he definitely they have more creatine phosphate in their muscle. And this formation of creatinine now, I'm clear. I hope you are clear how creatine is synthesized in our body. And we know creatine and creatinine are not same. And creatinine is, I told you, that is byproduct of creatine metabolism or creatine phosphate metabolism. And that is another form of creatine. See, we have creatine, first we synthesize from three amino acid, glycine, arginine, methionine. We added one phosphate molecule with the help of ATP, and the enzyme was creatine kinase or simply creatine phosphokinase. And the product is phosphocreatine or creatine phosphate, and the ADP is released. And now, suppose you have creatine and spontaneous non-enzymatic cyclization. Spontaneous means no need of any enzyme. Remember this line again. in our body, most of the reaction happen with the help of enzyme. These are called enzymatic reaction. But some of them are uh, really different. They are called spontaneous reaction. That means they don't need any enzyme. Suppose you have a creatine, and if you remove one molecule of water from it, it will definitely convert into creatinine molecule. Or you have a phosphocreatinine and this inorganic phosphate removed, again we can produce creatinine. And this creatinine is excreted through kidney and ultimately in the urine. And we have a very high amount of creatinine in our urine. Yes, how it degraded, it's very simple. Creatine and the creatine phosphate spontaneously form creatinine as in the product. That means you can say new definition, creatinine is in product of creatine phosphate or creatine, you can say like it. Creatinine is a waste product, one definition. Creatinine, an anhydrous form of creatine, second definition. Creatinine is a in product of creatine phosphate, that is third definition. You can say anyone. Creatinine is excreted in the urine, we already said that. And serum creatinine is a sensitive indicator of kidney disease, kidney function test. This is a very interesting one. Yes, you have heard many times many people have kidney failure or something like that. And this urea or creatinine are the very good marker to check whether kidney is working or not. And definitely this creatinine molecule has no direct relation with kidney, but still we are using this creatinine as a marker of kidney function. That why that is. The answer is, suppose we have creatinine in our muscle, and the amount of creatinine synthesized, whatever amount we synthesize, almost 95% is excreted through kidney in the urine. But if our kidney is not working, that time the filtration is disturbed in nephrons definitely, and the rate of filtration or GRF decrease, and the formation of urine also decrease, and excretion of urine also less. That means suppose you have nearly 2 or 2.5 liter of urine in 24 hours. But if there is a renal failure, either it is acute or chronic, there is a less amount of urine synthesized every day, maybe 500 or 1000 ml only. That time, suppose in your, if you are excreting 2.5 liter of urine, definitely there will be a 50 or 100 gram of creatinine in your urine. But if the excretion rate of urine is very high or very low, that time definitely the excretion rate of this creatinine will be low. That means that creatinine will be high in the blood. That's why we measure just the blood creatinine level for this kidney disease patient. If we get this is high amount than normal level, it's normally 0.5 to 1.5 or 1.3 mg per dl in our blood. If it is very high, we will say, oh, your kidney is not working very well. That's why serum creatinine is a sensitive indicator of kidney disease. And we generally ask in BIBA or in practical examination, why creatinine is very sensitive indicator of kidney disease. Remember this. Yes, serum creatinine increases with the impairment of kidney function. We said what is the reason behind that, because every day the creatinine is excreted with urine, but when there is a kidney disease, the volume of urine is decreased. That's why the amount of creatinine should be excreted in the urine is less, and that increase accumulate in the blood. That's why there is a high amount of creatinine in our blood. Yes, now see this. We have creatinine. Again, remember this. This is synthesized from 3 amino acids. We are very clear now. These 3 amino acids are glycine, arginine, and methionine. We have 2 enzymes there, transferase and the aminotransferase. There are 2 enzymes. One is methyltransferase. These 2 enzymes working, one in the kidney, another in the liver. Once these creatine is synthesized from 3 amino acids, that can transport it to the skeletal muscle or cardiac muscle. In skeletal muscle or cardiac muscle, one phosphate molecule is added, that creatine molecule in the presence of creatine phosphokinase enzyme. and that product is called creatine phosphate. This is actually energy giving substance, not creatine. Creatine phosphate gives energy actually. And now this creatine phosphate, if we uh, uh, remove one inorganic phosphate, creatinine will synthesize. Or if we remove one water molecule from it, it also produces creatinine. This is waste product actually. Now we are clear, this is the energy compound, these are the energy compound substance, but this is the waste product now. So what is creatinine? We can say this is the waste product of creatine metabolism or creatine phosphate metabolism. We can say this is the end product of creatine phosphate or creatine substance. Or we can say this is the anhydrous form of creatine molecule. See, because anhydrous means water molecule is removed and the dehydration was created, and that's why it's anhydrous form of creatine. Now, this creatinine is in the blood, and that blood goes to the renal artery, and there are efferent and efferent arterioles, and definitely then they filter, and there are nephrons and accept cell and proteins. Almost everything is filtered there. However, reabsorption nearly 99% there, and that creatinine ultimately filtered as a urine in the urine. That's why there is a very high amount of creatinine in our urine. But just remember what happened if our kidney is not working. That means there is a global filtration rate is low. That means our urine production rate is very low. And if there is a low production of urine, definitely low excretion of creatinine also. And that creatinine, which is synthesized in a constant manner in our skeletal muscle, definitely accumulates into plasma or blood. And when we measure that, definitely very high. That is why we are saying that creatinine is a very, very sensitive marker of kidney disease. Yes, excretion, we know that creatinine is a waste product of creatine phosphate, and it will be excreted by the kidney in the urine in the rate of 1 to 2 gram per day. See, 1 to 2 gram is a very, very high amount, because gram in blood, it's in milligram. Just I said it's a 0.5 to 1.5 milligram maximum. But the excretion rate, see, 1 to 2 gram per day. That means 1 gram means 1,000 milligram, or 1,000 to 2,000 milligram urine creatinine can be excreted in our urine if our kidney is working properly. But if there is a kidney disease or impairment of the synthesis of urine, that time the rate of excretion of this creatinine will be decreased. That's why that is accumulation in the plasma or blood, and there will be a high amount of creatinine in our blood. And on the basis of that, we can say, oh, there is a problem in your kidney. Yes, approximately 2% of the body's creatinine is converted to the creatinine every day. See, approximately 2% of body creatine is converted to creatinine every day. Even that creatine phosphate or creatine molecule is not being used as a source of energy, because suppose you are just in a resting position, you don't need any energy, instant energy. That time even that creatine phosphate is spontaneously metabolized nearly 2% every day. Creatinine is transported through the bloodstream to the kidney. Yes, these creatine molecules are transported through blood to the kidney. The kidney filter out most of creatinine and excrete it in the urine. Yes. Almost all creatinine filtered in the kidney and excreted through the urine. The diagnostic function of creatinine, yes, you remember this is very, very useful, especially when we are in a clinical setup. If the kidney are damaged or impaired and cannot work normally, what happens? The amount of creatinine in urine goes down while its level in the blood goes up. That means in our body, the synthesis of this creatinine level is normal, because we are getting almost a similar amount of energy or creatine phosphate metabolism. But the production rate normal, however, the excretion rate through the kidney is low. That's why the high amount of creatine is found in our blood. Creatine has been found to be very fairly reliable indicator of kidney function, because it's not being excreted in the kidney. That's why it's in the blood. serum creatinine level is an important diagnostic tool to assess renal function. Yes, there are many other tests which should say RFT, that is renal function test. Sometimes we say KFT, that is kidney function test. There are other biochemical parameters also, but the creatinine is the very important one. We measure urea also. We measure electrolytes like sodium and potassium also. We measure uric acid also. But the most sensitive one is creatinine because it's very constant and it's not directly related to kidney. Just its role is to filter all out. Level of creatine blood depends mainly on renal function. See, yes, the level of creatinine or blood creatinine level depends on the kidney function, we should say. But there are other conditions which may interfere our diagnosis. Is there other factors which may affect creatinine level in the body? Yes, there are other some factors. Serum creatinine may be affected partly by the amount of muscle tissue. That means suppose one girl is there, you measure just her serum creatinine, you get just 0.6 milligram per deciliter. At the same time, if you measure one bodybuilder main serum creatinine, you find 1.8 milligram of deciliter. That means it doesn't mean that bodybuilder kidney is almost damaged. You can't say that, because we are saying that the amount of creatine phosphate is directly proportional to the mass of muscle, and the more the creatine phosphate in our muscle, more will be the creatine excreted in our blood, urine. That's why it is directly proportional to the mass of muscle. That means more the muscular men have a high amount of creatine in their urine. The amount of muscle tissue you have, men tend to have higher level of blood creatine because they have more skeletal muscle tissue than women. Yes, more, that means not in number, it's in volume. Male are generally more muscular. Yes, they have a six-pack easily. It's very difficult to make six packs for girls. Yes, next, protein in diet. Another factor is protein in diet. Vegetarians have been shown to have a lower creatinine level in blood compared to non-vegetarian. Just compare one. It's not significant that if they have low or high, they have a problem in kidney. No, that's not. Just a comparison we do this, because when we are eating more meat products, we have more arginine, more glycine, more methionine, and definitely when we have more raw material, we have more creatine, and definitely more creatine will further metabolize into creatine phosphate and ultimately into creatinine. That's why there is another possibility of this type variation. Yes, now this is the most important one, enzyme creatine kinase, or sometimes we can say creatine phosphokinase. Both are same. See, we have creatine, no doubt. This is the metabolic product of 3 amino acids. Yes, and the creatine kinase is responsible for the generation of energy in contractile muscle tissue. Creatine kinase level are changed in disorder of cardiac and skeletal muscle. See, sometimes if there is a lack of enzyme, there is a possibility of this metabolic disturbance also, because these enzymes are present in muscles. And see, this creatine further metabolized into creatine phosphate. Very simply, there is one enzyme that is creatine kinase, or simply creatine phosphokinase, whatever you say. And CK is required for conversion of creatine into creatine phosphate. Yes. Sometimes we ask in MCQ, which enzyme is required for conversion of creatine into creatine phosphate? That time we put 3 or 4 and 3 wrong enzymes and one definitely true answer, and that time you have to memorize what is the best answer. And it has 3 isoenzymes. This creatine phosphokinase or creatine kinase has 3 isoenzymes. If you remember from the basic class of enzyme, we learned enzyme, coenzyme, isoenzymes, apoenzyme, holoenzyme, many terms are there. And yes, isoenzymes, they are almost multiple form of one enzyme. It has 3 isoenzyme. And remember these, CKMM, CKMB, and CKBB. These are the three isoenzymes. We generally ask in exam what stands for CKMM or CKMB or CKBB. That time MM, that is mainly in the skeletal muscle, MB in the mainly in heart, BB is brain. That means M for muscle, B for brain. Remember this. And this CKMB is a very, very specific enzyme for cardiac tissue damage. Like suppose you are in emergency room and one patient come to you and having chest pain. He was a hypertensive, a chronic smoker, family history of cardiac disease, and that time you just did ECG, electrocardiogram, you found that there is a elevation of that QRS graph, and you are thinking that, oh, you maybe have a myocardial infarction or heart attack, we should say. And at that time, to confirm or to support your diagnosis, you just need to take out 1 or 2 ml of blood from that patient and send to the biochemistry laboratory and to measure the CKMB level. And generally it's below 25 milligram per deciliter. If it is very high or double or triple, then definitely that patient have myocardial infarction. But this level of the CKMB increase after attack of myocardial infarction 3 to 4 hours after only. That means if patient come to you immediately after chest pain or difficulty in breathing or something, the symptoms which are related to myocardial infarction, and you just measure CKMB, you may not get very high value because it will increase after 3 to 4 hours only. That means these specific enzymes or isoenzymes can be used as a diagnostic tool for different disease. Suppose you want to see the level of CKMM, particularly when a person having electric shock, that time we measure this, but it's not generally we use, because to measure how much muscle mass has damaged, just rule out that, but it's not that much common. And CKMB is very, very common test. We do almost every day, 3 to 5 tests we are getting in our laboratory for this. CKBB we are not doing. However, some neurological or neuro hospitals they might do. And serum total CK is increased in cross injuries, damage to skeletal muscle. Suppose there is a RTA, road trauma accident, or other injuries. That time this creatine kinase total means all of these together, CKMM, CKMB, CKBB. We measure this all in one test that is called serum total creatine kinase or creatine phosphokinase. That we have CK total is one test, our individual fragment CKMM, CKMB, CKBB, we have individual one. But whenever we have a very cross injuries and there is a loss of muscle damage, skeletal muscle, that time the CK total is very useful tool to predict the damage of muscle. Myocardial infarction damage or this myocardial infarction for this CKMB only, because mainly in heart muscle. That's why if we measure this, we can easily rule out that whether there is a cardiac muscle damage or not. Yes, this much today, and hope you learn some. And I will happy if you ask some question. Anyone there to ask?
Sir, can you send the slide of this class and the last class?
Last I sent you, remember? No, not last. I think
you sent of neurotransmitter.
Oh, I sent just the first one. Okay, I will send you that previous one about that muscle, skeletal muscle metabolism, and this one I will send to you your mail.
Yes, thank you, sir.
Yes, and don't forget that you have to memorize this creatine metabolism very finely, because this is very, very important question. And once you understand this, then next will be what is the next source of energy for muscle construction, because this is instant source of muscle energy. This is creatine phosphate. Next we will go for glycogen metabolism. Then we have a few other like Cori cycle and glucosylanin pathway. We will discuss continue. And yes, I will send in your email, but don't limit to these slides because we are just going to briefly discussing here, but you have to understand in the more depth. But if there is a difficulty to understand, just to write me email or you can ask here, no problem. But don't limit in these slides because here we have only 20 slides and we are discussing almost very much that is not included in the slide. That's why if you are just focusing on these slides, that is not sufficient sometimes. The best is you have to make your own notes, just gathering some notes from faculties and books and some other sources like good and valid internet sites, and then make your own note, which will be very, very helpful in your examination, because once you made yourself, that is really helpful to you. Don't just read and forget, because once you read only, you will forget very easily. That's why try to write. Once you write yourself, it's very, very easy to understand or memorize in future. Anything else? Hello? Are you there?
Yes, sir.
Yes, sir.
Yeah. Anything else you want to ask?
No, sir.
No,
Okay,
sir.
okay. Yes, I don't want to start another because it's we have 15 for 16 minutes, but next topic I can't finish, otherwise I can start the next one, but it's not easy to start and finish another topic in this 15 minutes. That's why I'm going to stop here, but hopefully you will learn and enjoying this class. Have a good day.
Sir, we don't have to study organophosphate poisoning in ANS.
Oh, OP poisoning. Okay, we will discuss. I forget that. Yes. Thank you very much. And yes, just to go through curriculum, and if I forget something, just remind me, please. Yes, we have OP poisoning. We will discuss that. Are you okay, sir?
Yes, sir.
Have a nice day.
Thank you, sir.